So you want to learn about optics and mirrors? Well, you're in luck, cause it's
Zardy Zia. And he's
not,
playing Minecraft.
but instead teaching simple physics of optics and mirrors. Mirrors are crazy. Left becomes right, right becomes left, and up and down remains the same. Mirrors come in two types, plane mirrors and spherical mirrors. Plane mirrors are the plane mirrors in the world, or the mirrors found in bathrooms and stores. All the glass in the plane mirror is on the same plane. The objective distance is always equal to the image distance in a plane mirror. The law of reflection states that the incident angle is always equal to the reflected angle. While looking at an image in a mirror, there are reflected rays of light from the mirror to the eye. When light hits a surface at a low angle, like on a lake at sunset, it bounces off at the same low angle and hits your eyes full blast, rather than obliquely as when the sun sits overhead. This is why the sun's glare during the evening and morning is so much more intense than during the rest of the day. However, not all surfaces are perfectly even. A diffuse reflection is how our eyes interpret light as it hits an uneven surface. The law of reflection still applies, however, light is hitting many microscopic surfaces. Mirrors don't scatter light this way. Mirrors utilize specular reflection. Mirrors flip images left to right as mirrors actually switch front and back. Spherical mirrors don't have reflections in all the same plane. There are two types of spherical mirrors, concave and convex. To get an idea, a common type of concave mirror are makeup mirrors. These types of mirrors magnify the object close to them. The most common type of convex are the passenger side mirrors on cars. Convex mirrors offer a wider field of view and make items look smaller than they really are. Some department stores have placed convex mirrors in their dressing rooms, and slight bends at the top and bottom make you appear both taller and thinner. Concave mirrors can bounce light to a specific area in front of them. This area is called the focal point. From far away, objects will appear upside down. However, once you pass the focal point, the image flips and actually magnifies. There exists a line passing through the center of the sphere and attaching to the mirror in the exact center of the mirror. This line is known as the principal axis. The point in the center of the sphere from which the mirror was sliced is known as the center of curvature. The point on the mirror surface where the principal axis meets the mirror is known as the vertex. The vertex is the geometric center of the mirror. Midway between the vertex and the center of curvature is a point known as the focal point. The distance from the vertex to the center of curvature is known as the radius of curvature. The radius of curvature is the radius of the sphere from which the mirror was cut. Finally, the distance from the mirror to the focal point is known as the focal length. Since the focal point is the midpoint of the line segment adjoining the vertex and the center of curvature, the focal length would be 1/2 the radius of curvature. Concave mirrors follow two rules of reflection. One being that an incident ray traveling parallel to the principal axis on the way to the mirror will pass through the focal point upon reflection. The other rule states that an incident ray passing through the focal point on the way to the mirror will travel parallel to the principal axis upon reflection. These same two rules can also apply to convex mirrors with minor adjustments. Any incident ray traveling parallel to the principal axis on the way to a convex mirror will reflect in such a manner that its extension will pass through the focal point. any incident ray traveling towards a convex mirror such that its extension passes through the focal point will reflect and travel parallel to the principal axis. Mirrors are objects currently being used for various things, whether it be viewing our own image, keeping ourselves safe, aid in selling clothing, or magnifying specimens for further study. Mirrors are a wonderful, complicated part of the world that we cannot live without. So what exactly is optics? Optics is a branch of physics that deals with the property and behavior of light. There are three main branches of optics: geometrical optics, the study of light as rays; physical optics, the study of light as waves; and lastly, quantum optics, the study of light as particles. When the sun peeks through clouds, observers see rays of light peek through. Early scientists used geometry to model these rays of light. Two laws dictate what happens when light hits a surface. The law of reflection states that when light hits a flat reflecting surface, the angle of incidence equals the angle of reflection, the angle formed by a reflected ray. The second law, the law of refraction, explains how light rays change direction when traveling through a medium. This can most easily be compared to when an object is half submerged in water and appears to be bent. The general use of geometric optics is determining how rays of light travel through complicated optical systems like telescopes. Pretty cool, huh? Physical optics studies light as waves rather than rays. Physical optics can be broken up into three areas: interference, diffraction, and polarization. Interference is the ability of a wave to mess with itself, creating areas of extreme brightness and also areas of extreme darkness. Diffraction is light's ability to bend around objects and spread out through an aperture. Polarization is referring to properties of light related to its transverse nature. Sound waves and their properties can be near directly correlated with light waves and their properties, but unlike sound, however, light can't really be measured, as a wave is much smaller than that of sound. So small, in fact, that it can't be detected by the human eye. Quantum physics studies the individual particles of light known as photons. Light has both wave-like and particle-like properties, making light have wave-particle duality. Then individual particles in light build up into a wave-like pattern. All three categories are still being used today. Geometrical optics studies rays of light in optical systems. Physical optics is used in engineering and real science. Quantum optics is used to understand quantum mechanics, something I'm not going to get into because I don't understand that. And is being used in quantum computing and quantum cryptography. I mean, the drop's like, I don't know, my height, and a 6-foot drop if anyone cared. Come on. Look at my baby. Look at my baby. He's my baby. Oh, he's my baby. Oh. Good baby. He's a good baby. He's a good boy. When light hits a flat reflecting the angle of reflection, cool, huh? Light goes out.
Minecraft.